जी अस्सलाम वालेकुम. My name is Professor Mohammed Salman. Today I am going to explain the topic hybridization. First of all, time is very short, and I will try to understand to hybridization. What is meant by hybridization? Process of intermixing of atomic orbitals which have different shape and different energy. When they overlap with each other, they form same energy and same shape orbital, same energy and same shape orbitals. These orbitals are called hybrid orbital, and this phenomenon is called hybridization. For example, this is s orbital and this is p orbital. X-axis along 2px, 2py, and 2pz. When these orbitals overlap to each other, they form a hybrid orbital. There are three different types of hybridization. Number one, sp3 hybridization. Hybridization. Second one is the sp2 hybridization. Hybridization. And last one is the sp hybridization. Sp hybridization. In sp3 hybridization, one s and three p atomic orbitals overlap to each other. They form four new hybridized orbitals which have same shape and same energy. These orbitals have different shape and different energy. When they overlap to each other, they form a hybridized orbital and the shape and energy will be same. The best example of sp3 hybridization is methane. Now I am drawing the structural formula of methane. This is a hybrid orbital. Now we draw the structure of methane. The molecular formula of methane is CH4. Now we put the electronic configuration. Carbon belongs to four groups. The atomic number of carbon is 6 and 12. Atomic mass were 1s2, 2s2, 2px, 2py, and 2pz. 2 plus 2, 4, 5, 6, 0. This state is called ground state. Now electron jump from 2s2 to 2pz. This state is called excited state. In this hybridization, 1s and 3p atomic orbitals overlap to each other. They form four new hybridized orbitals are formed, and this is also called as 4sp3 hybridization. Okay. Now we will draw the structure formula of methane. This is the structural formula of methane. Methane shows a 4 sigma bond and there is no pi bond. How we can draw the sigma bond? Sigma bond head to head overlapping they form a sigma bond and parallel overlapping they form a pi bond. In the structural formula of methane there is no pi bond and they have 4 sigma bond. The bond angle between this structure is 109.5. Shape name is tetrahedral. Tetrahedral. S character 25% and P character will be 75%. This is the tetrahedral geometry of methane. There are various examples of sp3 hybridization like methane, ethane, propane, and so on. Other than methane, organic compound, water is the example of sp3 hybridization. Ammonia is the example of sp3 hybridization. Methane is the example of sp3 hybridization. These are the examples of sp3 hybridization. Now I am drawing the structure of sp2 hybridized orbital. What is meant by sp2 hybridized orbital? When one s and two p atomic orbitals overlap to each other, they form three new hybridized orbitals are formed. Such hybridization is called sp2 hybridization. In sp2 hybridization, the best example is ethene. How we can draw the structure of ethene? We know the molecular formula of ethene is C2H4. Now I am drawing the electronic configuration 1s2, 2s2, 2px, 2py, and 2pz. This is the ground state. Now I am drawing excited state 2px, 2py, and 2pz. One electron jump from this S2 to S2pz, and this orbital is hybridized orbitals, and these are called 3sp2 hybridized orbitals. 3sp2 hybridized orbital. Now we draw the structure formula of ethene. This is the three orbitals. Now we draw the unhybridized orbital. This orbital is unhybridized orbital. This shows the color, different color, and unhybridized orbital is shaded. Okay. Head to head overlapping they form a sigma bond, and side by side overlapping they form a pi bond. The above and below they form a pi bond. In the structure of ethene, there is a 5 sigma bond and only 1 pi bond. Okay. The bond angle in the structure of ethene is 120, and the shape is trigonal. Trigonal. S character 33% and P character will be 67%. This is the example of sp2 hybridization. Now I will explain the sp hybridization. When one s and one p atomic orbitals overlap to each other, they form two new hybridized orbitals are formed. Such hybridization is called sp hybridization. The example of sp hybridization is ethine. Ethine. I am explaining the example, organic examples, only organic examples. Actually, hybridization of sp hybridization, organic as well as inorganic, most examples are available. Those molecules have linear structure, they show the sp hybridization. Ethine C2H2. Now I am drawing the structure formula of ethine. Electronic configuration carbon 612, 1s2, 2s2, 2px, 2py, and 2pz. This is called ground state. 2s1, 2px, 2py, and 2pz. Now these are unhybridized orbitals. 1s and 1p they form 2sp hybridized orbital. Now I am drawing the structure formula of ethine. This is x-axis, this is y-axis, and this is z-axis. Now this is x-axis, y-axis, and z-axis. Y and z are unhybridized orbitals. I am shading unhybridized orbitals. This is 2p y, and this is 2p z unhybridized orbitals. Now we know that head to head overlapping they form a sigma bond, and side by side overlapping they form a pi bond. How many sigma and how many pi bonds are present in the structure of ethine? There is 3 sigma bond and 2 pi bond. 3 sigma bond and 2 pi bond, which is present in the structure of ethine. Okay, the bond angle between this structure is 180, shape is linear, S character 50% and P character is also 50%. Now the question is that okay, how we can check out the which molecule shows a hybridized orbital. Which type of molecule shows a hybridized orbital, which type of hybridization is present in different structure. Now I am telling about that one. for example, if we don't know what is the hybridized state in the structure of methane, methane CH4, there is a very simple formula, number of sigma bond plus lone pair is equal to our answer. If our answer is 2, then hybridization state is sp. If our answer is 3, sp2. If our answer is 4, sp3. If our answer is 5, dsp3, d2sp3, d2sp3, 6, sorry, dsp3, d2sp3, and so on. Okay. Now we will check. This is a central carbon atom. There is 4 sigma bond. There is no lone pair. 4 plus 1. It's 4 plus 0. It's mean 4. Answer is 4. Then which type of hybridization is present in methane? Methane show the sp3 hybridization. Now we will check these PCl3, phosphorus trichloride. Phosphorus trichloride, this is a central atom, and there is 3 sigma bond. There is no pi bond. There is no pi bond. So 1, 2, and 3. This is this show the sp2 hybridization. Now I am giving the example of formaldehyde. This is a structure formula of formaldehyde. Formaldehyde belongs to carbonyl group. Carbonyl group, this is formaldehyde. This is also called as methanol, formaldehyde, and so on. Second metal atom, we look at carbon double bond. This show the 1 sigma and 2 pi bond. 1 sigma, and 1 sigma. Almost three bonds. There is no lone pair. 3, so it's mean sp2. Formaldehyde show the sp2 hybridization. Now we will check the structure formula of ammonia. Ammonia show the how many lone pair, 1 lone pair and 3 bond pair. 3 plus 1, 4. So it means ammonia show the sp3 hybridization. So it means hybridization is a very interesting topic. Hybridization basically mixing or intermixing of atomic orbital which have different shape and different energy. When they overlap to each other, they form same energy and same shape orbitals. These orbitals are called hybrid orbital, and this phenomena is called hybridization. The simple example of hybridization is mule. If we cross the male horse and female donkey, then mule will be formed. This is the example of hybridization. If we intermix atomic orbital like s orbital and p orbital, which have different shape and different energy, when they overlap to each other, they form a same shape and same energy orbital. These orbitals are called hybrid orbital, and this phenomena is called hybridization. Thank you very much.